I just bought these 12 volt LED headlights on the internet for $8. That's for 2 LEDs. So $4 each. That's even cheaper than one single older style energy sucking dinosaur power heat lamp. And in fact, Walmart is selling it for $8.75 for each. I got 2 of these for $8. That's $4 each. Yep, that's all I can afford because I'm so poor. I can't even pay attention. I'm going to do a full review for this LED, and also I'm going to do 3 comparison tests between the 2 light bulbs. The first one is the power test. See which one produces less power. Of course, this will produce less power, but how much? The second test is the lumen test, and I want to see which one is brighter. And the third test is the real light test. You see which one is brighter. So let's get started. This LED comes with 4 COB LED strips on 4 sides. COB stand for COB, stand for chip on board, and it's very bright. It's mounted by 2 small screws, so it can be easily replaced if it goes bad. But the hard part is where you're gonna find this LED strip to replace it. It has aluminum body, aluminum heatsink, 12 volt fans on the bottom here. The connector does not have a little plastic tab inside, and therefore you can connect it either way. However, you have to connect this with the right polarity in order for the light bulb to work. Positive on the right side, negative on the left side. But for my car, the connector on the car with the latch on the top, the positive is on this side, negative is on this side, so I have to turn this upside down in order to connect it in correctly, otherwise it won't light up. And fortunately, the LED controller inside here has a reverse polarity protection, and therefore if you connect this reverse, it just won't light up, but it doesn't burn out the LED. Dimension is about 3.5 inches long. The fan is about 1.25 inch in diameter, which is pretty small for the amount of heat this LED is producing. I have tried this on my car, and it's very hot back here. So the lifespan of this LED depends a lot on this fan. In fact, if this fan dies, this LED will die immediately. If I really want to make this last longer, I probably have to remove this fan and put in a computer fan or something bigger than this. Next step, I'm going to do some comparison tests between the 2 light bulbs. And the first test is the power test. I've got my 12 volt lead acid battery here, voltmeter and amp meter, and we're going to compare how much power each one produces. I'm going to connect it and ready to go. The first one is the LED light bulb. I got it wrapped up in aluminum foil because it's going to be very bright and it's going to be blinding to the camera and we won't be able to see anything. Here we go. Let's see how many amps we got. About 1.9 amp. 12.46 volts. You can hear the fan is not very loud. I would say it's acceptable level. Your engine is a lot louder than this. It's hot. I only ran it for like 1 minute and it's hot to the touch. I can't hold it for too long. So definitely without this fan, this LED will burn out very quickly. Next step is the halogen light bulb. This bulb is so light I have to use my lead solder to hold down the cable, otherwise it will just move around. Actually it weighs only 15 grams, that's 1.5. This thing weighs 60 grams. Alright, I'm ready to go. Wow, produce a spark. Shows how much power this thing consumes. And look at the voltage drain. it pulls down the battery voltage a lot more than the LED. See how much current? 3.94 amp. Wow, that's over twice the power compared to the LED. And I'm already smelling something coming out of here. Probably burning something down here. Alright, disconnect it. Oh wow, this aluminum is hot. I can't even touch it. This light bulb is actually a heater. So here's a comparison between the two light bulbs. LED 23.6 watts, halogen 49.3 watts. So the halogen light bulb consumes more than twice the amount of power compared to the LED. No wonder why it produces a lot of heat. And the smell during the test for the halogen, because it was so hot, was burning the surface on my table. So the difference in power consumption is about 25 watts per light bulb. You got two light bulbs, therefore you save a total of 50 watts. And 50 watts is a lot of power, and that can translate into a lot of fuel saving. Next test is for brightness. So I want to see which one is brighter, the LED or halogen. I have a lux meter here, and it measures how much brightness coming out from a light source. The unit is lux, and you can certainly convert it to lumen. 1 lux is 1 lumen per square meter, but that's not important. The important thing here is that we can just keep the unit consistent. I have the light bulbs already installed in my car. On the right side is a newer LED. On the left side is the halogen. Alright, I'm ready for the test. I have to start up my car engine because and I'm going to put the lux meter right in front of the lamp, right here where this line is. Right there, right in the middle. See what we got? 4,300 lux. Now we're going to come over here to the halogen. Right on this line right here, right in front of the light bulb. Let's see what we got. 1,600. 1,700. So the third test is a field test, and I'm outside at the field, and I got a blanket here, and I'm going to use a blanket to cover on each side and compare the brightness between the two light bulbs. So first up is the LED, so I'm going to cover up the halogen on this side with my blanket here. Alright, let's see how bright it is. Alright, so that's how bright it is with the LED. And now we're going to cover up the LED. Let's see how bright it is with the halogen. Wow, totally different. Here's what it looks like from the same angle. And this one is the halogen only, and this is the LED only. Totally different. I have only run it for about 10 minutes, but the amount of heat coming out the heatsink is tremendous, which is a good thing because now the heat is pulling out of your light assembly instead of staying inside the light assembly. And too much heat inside here is going to damage the lens, which already happened on my car. And too much heat inside here over time is going to make your lens yellow, and it will block your light from coming out. So pulling the heat out of here is a good thing for my lens. Here's a summary of what we've done so far. LED versus halogen. Cost $4 versus $9. That's half of the cost. Power 24 watts versus 49 watts. That's half of the power. Brightness 4,300 lux versus 1,700 lux. That's 2.5 times more brightness. And lens damage, LED pull all the heat out of the lens housing, whereas the halogen, the heat stays inside the lens and therefore it will damage the lens over time. So which one would you choose, LED or halogen? Well, the answer is clear. I don't even have to say it. There's one more thing I want to talk about, but this one is just for fun. The power I save is 25 watts per bulb. So I got 2 bulbs. The power I save, total 50 watts. And that's like turning off 1 halogen light bulb if I have halogens on both sides. And in general, for daytime running light, DRL, if you turn off DRL, you're gonna save 1% of fuel per year. My car costs $1,000 to buy gas per year. So for 1 light bulb, I save half of that, which is $5 per year. That's not much, but that's enough to buy another light bulb just after 1 year. And this is a small car. A truck would cost twice as that. So $10, 2 light bulbs. So I can basically change 2 new light bulbs every year without feeling guilty. Anyway, to sum up, this LED is so cheap and efficient right now, there is no excuse to use the halogen light bulb anymore. I've been using the LED for about a week now and they seem to work fine. I just have to check the fan to make sure that they work, because if the fan is stuck or if the fan dies, the LED will die very quickly. Actually, this LED is so good, I think I'm gonna modify this LED and put it on my electric bike. That would be cool. What do you think? Maybe next project? But that's all for now. Thanks for watching. We'll see you next time.